client infra. Okay, so the data ES whatever it gets, right? Jaeger has to know where to store this. One data source should be there, right? So that we are storing it in Elasticsearch. So as of now, what we are doing, we are setting it as ES client infra. Okay, if this exists. If not, we are saying put it in the normal ES. In the because some clusters we won't put the separate Elasticsearch and all for infra. Maybe you don't have enough this thing and stuff. So in case of dev and QA clusters, right? In dev and QA clusters, for instance, we don't deploy Elasticsearch infra cluster. So there is no, you see there is no infra cluster. Others is there, but there is no infra cluster. Okay. Now, in this dev and QA, there's no point of having one more Elasticsearch infra just for Jaeger. So what we do is we just deploy the same thing. So for that, we have this clause which says if there is an existing ES client infra defined in the config map, that is in the environment file, if there is there ES client infra, you go and deploy there. Okay, you can see here. So it says if you have deployed a ES client infra in your cluster, then you will set this variable, right? So it will check if this variable will exist, then I will deploy and send the data to infra cluster. If not, I'll store it in the normal ES cluster. Okay, so that is the only config that Jaeger needs. Other than that, nothing else it needs. Normally, it will just deploy the components. So there are a few components which it deploys. One is the Jaeger collector. Okay, what this one will do is the pods which are sending this data to Jaeger, like the common eGov user, eGov collection services, all the pods, right? They will reach out to Jaeger collector. Okay, not exactly that, but rather they will reach out to the Jaeger agent. Jaeger agent is same as you how you saw that Fluent bit agent, right? What Jaeger agent is, it will be a daemon set which is deployed on each node. You see it? Okay, you can see here. Okay, so I'll explain one by one. First is Jaeger agent. What it does is one pod will run on each of the nodes. So if you have 10 nodes, 10 Jaeger agent pods will run. Okay, the reason for this is all the pods, right? They have to submit this so eGov user collection whatever it is, they have to submit their metrics into a place that is this Jaeger. Now if you deploy just one service like one pod and all the services will then push it to that single pod, then the communication will be internode. So across the node, the data has to pass, which means sometimes the application might end up doing more work in this IO related stuff. And because this is tracing and all that, right? Instead of doing business logic, most some time might get wasted here. The speed. So what we do is we deploy this agent as a daemon set so that now what happens, it will be exported as a service will be exposed as a node port. Now this node port will be passed on to the service, to the eGov user and stuff, saying send it to this. So it will be local communication, which will be much faster. One second. Hello.
Yeah.
Okay, so where was I? What was I saying? So that's what this one does. I'll show you the example also now. Okay, um, okay, here if you see, right, this is what it means. What we are saying is you connect, so Jaeger itself, this one we won't pass all these services, we'll just say wherever you're running, just send it to the same. So basically, if you're running the host, you do localhost 86831 and submit the metrics. That's what it says. Okay, is this clear? This part?
So in every Docker container, one daemon is running. You're saying, right, Jaeger?
No, 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 no. So this daemon is running in the node, every node.
Okay.
Okay. In that node, you can run, let's say, 10, 15 containers.
Mm-hmm.
Okay. Now all those containers can reach out to the within the same machine.
Okay.
So in your local also, right? Imagine you are running your machine, local machine. You are running in number of programs,
Mm-hmm.
but all of them can reach to the same Jaeger.
Mm-hmm.
So that's the concept. But if imagine you're running Jaeger on a different computer, then what will
Okay.
happen? You have to go through the network and submit to that computer Jaeger, right?
Okay, we got it. So
So the
on.
network.
Okay.
Okay. So what Jaeger agent will do, it will act as a buffer. So the applications will all submit to Jaeger agent and it will be disconnect from that and say my work is done. So application
Okay.
will not get slow. Then
Mm-hmm.
Jaeger agent will then figure out, okay, I have to send it to Elasticsearch. Okay, I will send it. It will use that as a buffer.
Okay.
Okay, so it will see how fast Elasticsearch is. It will slowly start submitting it. But the applications are free. Once they will submit, they'll just finish their work.
Mm.
Okay, so that is Jaeger agent. Okay. Now Jaeger collector is not, it doesn't do a lot of things. Okay, so see the Jaeger collector, right? See this part, sampler. So what this does, Jaeger collector is, which service, how much we have to sample. So normally Jaeger has a sampling strategy. One is constant, means every request that comes, you sample it, means get the details of that request. Other is sample 50%, 10%, probabilistic sampling of 20%, something like that. Many sampling strategies. So that strategies we can define in Jaeger collector. Okay. But as such, I mean there is no involvement of, like, it's just general knowledge. I'm telling that what Jaeger collector does. But yeah, it's, you don't exactly use this per se. It'll get used internally. Now Jaeger query is your front end. What your front end runs, that queries are coming to this Jaeger. Now this Jaeger query will in turn contact Elasticsearch and do. But again, it's all general information. You'll never have to do anything, any changes here or anything like that. Okay. One more is Spark dependency. This is a job. What this job will do is it will present you this graph. Okay. This simply we run in case we need. You have this, right? You have this tag kind of thing. Like how many calls are coming to each service and what's happening, what is the dependency, that sort of thing. That one, that is what this one will show.
So what is Spark used for exactly?
It will go to that Elasticsearch has collected all the data, right?
So this analysis you're running in
Yeah,
Spark.
this analyze
Okay.
one, this runs as a batch job. What it
Okay.
says is now PT calculator. How is PT calculator? Yeah, calculator reaches billing service, and billing service also calling PT calculator by directional. It's also calculating calling MDMS collections. Okay, it makes those this thing. Now you see eGov user. How many people make call to eGov user? And there are a couple of exits, which is MDMS and encryption service. Rest everyone makes calls to eGov user. Okay, this graph is generated by the job. Okay.
Okay.
Again, here also not much to do. It will automatically keep happening. You don't have to. So Jaeger is one of those services that basically requires no maintenance. Once you deploy it, it will keep working. Okay. Now this is the infra part of it. Now the second part to it is how do you deploy and how do you enable in the service. Now whenever it says Jaeger is not working, we are if DevOps side, what actually it is are these pods deployed and are they working? Jaeger related. That's all. Okay, are these pods running? That's all. And most likely they will never. Usually, I've seen many services, and this is one of those services which are really rock stable. They never really fail. Okay, so the idea is Jaeger is working. Okay, is this started? Is this portal running? That is the most important. Now, other questions might come. Okay, there is one service is not there. I have deployed it, but it's not showing here. That is the other question that comes. Now, this part is like I told you, Jaeger is just the infrastructure is Jaeger is running. Now somebody has to submit metrics to it. Only then can it show something here. Okay, until somebody submits metrics to the Jaeger portal, nothing comes. Now, how do you enable that? So one thing is there are two flags. First of all, in all it works on Java services. We return the tracer library, right? That tracer library on enabling the tracing enabled flag. Okay, on enabling the tracing enabled flag, we are passing. We will create these additional variables. We will deploy these additional env variables to the service, which says when you set all of these variables, it will start producing the traces. Assuming tracer is configured properly, then yeah, like tracer is added to that application and there's no problem with that tracer and that version of Spring Boot and all of that, it will start sending the traces. Okay. For that, the requirement now is you either enable it for each service per service wise by setting this. Okay, or the other way is setting it globally. You can set it here and it will still enable across. Okay, now if there is no tracer library or if there is nobody is sending traces, then of course Jaeger will not show any results. Now Jaeger, the infra part is it is ready to receive and ready to show as long as somebody submits traces to it. Now if the application itself, like your user collection service, not submitting, then you won't get any data to it.
So there is nothing to be instrumented in the code or something, right?
No, no, it is. So the instrumentation has to happen in the code, okay, in whichever service. But what is done is we have abstracted it to a single library, and that library is part of all our Java services. And since that is part of that, we can now turn it on and off with just a environmental variable.
So you want to quickly show that piece of code?
Yeah, sure. So that I think Aniket, no. Okay, so tracer, this is there, and then it's a bit laggy. So, okay. There will be two of them. Okay, these two classes are there. This is all there is for tracer. So what we do is we will add for the rest template, right? This rest template is what we always use, and in this template we will add an interceptor. Okay, and then whenever it's enabled, we will start a tracing this thing, and same thing. Whenever we are enabling it, we will create a tracer. If it is false, then we will say a no op tracer, which means it does nothing. Just about two classes, nothing much. This is the interceptor.
Yeah, this is a common library, but within a service, how this library is being called?
That is so. This is their part of every our all our code. Okay. So whenever this thing is there, what we do is we add this thing, import tracer configuration. This is there always. Like all our Java services has it. So this has to be there. That's all. This line of code. Once
Okay.
this is added, then automatically your application will be ready to send traces if you want it. So if you enable the flags appropriately, then this will start.
Within if like from other app, that JavaScript or Python app, I have to send the data. So I'll have to call that Jaeger API only, right, to send in the metric.
No, I mean, I don't have to do so much. So like open tracing, Node.js, there will already be
Already there are implemented.
all of the, even ours now, whatever we've done, right? Even that we have not added all of it. It's also it's like we've not created our own code. We've imported libraries only here also. See,
Okay.
right? Open tracing, all our libraries and nothing. We've not written anything. We just reuse the code for whatever is there. They're
Okay.
automatically maintained now. Here also you can see now what is how you need to include the library, and once you include the library, then everything will automatically happen.
Okay.
These libraries are there for everything. Okay, Golang, whatever it is, everything will be there already.
Okay.
Of course, you'll have to just go through what it is, what is doing, and then appropriately do it. But apart from that, the entire thing will already be there for Python, JavaScript, C++, everything. It is already there. Okay. Again, the store here it will store it, Jaeger and all, but you won't query these things. You will actually go to the Jaeger portal and check it out. Now, but Jaeger query will internally call this Elasticsearch to get its data. Okay, so the logs have now started. Okay, 5.1 billion. As long as it started, even this case, there's not much debugging actually supposed to. You just like we shared in the video, right? The flow is simple even in logging terms. The flow is from FluentBit will collect the logs. It pushes to Kafka. If messages are coming to Kafka, then Kafka Connect has to be present. Kafka Connect has the correct Elasticsearch URL. Then Elasticsearch is up. Then the logs will appear. Okay. So in this case, what has happened was the Elasticsearch Kafka Connect itself was not deployed. So it was going to Kafka. From Kafka, there is nothing to push it to Elasticsearch. Okay. So logging also. Okay, there's one more thing about logging we talk about. So in terms of when you're logging, there are normally what happens in DevQA most environments, we log with plain readable text, which means it's in console form, right? But in production and UAT, we log in JSON so that it's easier for us to visualize here. Okay, it's very easy for us to visualize here now. And you will get information as to how many error logs are there, how many won, how much. But if you do plain text logging, you won't get these things. Okay. Now to enable that, again, we have a flag which says production. Okay, okay. So we have this profile that we have to enable for production. Okay. So what does that does is we have a log back here which says when the profile is production, you log in JSON. Okay. JSON important. But if you are saying it's not production, just do the normal console wala login. Again, this is also part of Tracer, and now Tracer is included in every app so that at least every uh, Java app, and then it works. Node.js, usually Node.js will log in JSON only many times. So, and that's automatically there also, so you can do that. Okay, whenever you want to log and debug it nicely by Kibana, it's best to log it in JSON form. The application logs in JSON form, and when the application itself is logging into JSON, then it can easily be parsed. Okay. Any questions?
So that logging we are calling, that logging means just nothing but just this one, no? The Fluent bit, Elasticsearch, and
What?
infra thing, right? That logging thing.
Logging thing.
Yeah, means it's nothing but this combination, right?
Yeah.
Fluent bit, Elasticsearch, we are calling that logging.
Correct. Just check yesterday, the Friday's video also. Okay, once it has more detail. Okay, but
Okay.
that's what it is. First, Fluent bit will collect logs from the containers. It will push it to Kafka. Then Kafka will from Kafka you can create a Kafka Connect config, which will push from take data from Kafka, push it to Elasticsearch.
Okay.
So normally you could also do Fluent bit to direct Elasticsearch. So you
Mhm.
won't have Kafka to Elasticsearch. That two components will miss. But again, this was Abhishek's thing that he wants to go through that. If that is not required, then you won't need Kafka also.
Okay, directly
And
stored in Elasticsearch.
Nitin, we add this what is that? Some correlation ID, right?
Yeah.
So where it's part of where do we add that? Like,
So correlation ID is added in Zool.
right?
At the API gateway level, we add the correlation ID in the
Okay.
request.
But
Okay. And again, I showed you the logs right here. There is a single logging method we use, and here I will then in this logging pattern that you can see. Okay, so here you see you're printing MDC here. Okay, which means MDC is just that it's the thread context, and here in the thread context we add the correlation ID so that this is getting outputted there. Okay, every time whenever this is the logback config details. If you Google for logback patterns, then you will get the config like what this exact each line each word means. But then when it says percentage MDC, it will dump whatever is stored in the MDC. And now if you see here the filter itself, right? We are adding the MDC, adding the filter MDC. Okay, so we add this MDC, we add the correlation ID. And since you are adding it here, then every service will then print the correlation ID. And since you are logging in JSON, it's now easy to search on that correlation ID. Okay. Same with the tracer thing. If you see, okay, you're setting the interceptor here. Now the interceptor, you in the span itself, you will add the correlation ID. Again from the MDC, you'll get it from the MDC add. So that same correlation ID will get propagated from Zool. First it gets added in Zool. From Zool, the first tracer interceptor, REST interceptor will pick it from that request coming in. Then it will parse the body, get the correlation ID. If not, check the header, pick that correlation ID, put it in the MDC. So once it's there in the MDC, it is available throughout the life cycle of that request. Then you can use it wherever, whether to log or trace or wherever you want, you can use that correlation ID.
And one more quick thing, Nitin. How does Zool know? This is a fresh request or a internal request from a service. How does it determine to add the
Request won't go to Zool at all. Only fresh request from the external internet only it comes to Zool.
in all the cases? Huh?
Yeah, yeah.
Yes, absolutely.
No, there are other systems also, right? Like we had external Kibana and stuff like that. Okay, yeah, everything goes through. Hmm. So if the if the correlation ID is not there, it will. I mean, Zool will add it, or rather the interceptors. If something is there, it will use the same correlation ID to tag everything, right?
Yeah.
But yeah, okay.
Mm. Then don't any more questions. Let's take one more questions.
No.
Another?
No, it's